start in Unit 6 in the Blended Algebra 2 course. This unit is on exponential functions. So things we've done in the past in this unit, linear functions, we've also done quadratic functions, but we're going to focus on linear to start here because we've talked about those lines a lot since Algebra 1 and also since middle school pre-algebra. Linear functions are of the form usually y equals mx plus b. Now the difference here, these new functions called exponentials are of this form. Y equals a times b to the x. X is an exponent, which makes sense because these are exponential functions. Here, a is called your starting value, also known as the y-intercept. So a, that first number, is the y-intercept. B is what we call the growth rate. So the growth rate tells us if the function is going to be increasing or decreasing. When the growth rate is bigger than 1, we're increasing. If it's less than 1, we're going to be decreasing. So let's look at some examples. All we're going to do here to start is decide if we're increasing or decreasing and state the y-intercept. So the y-intercept, remember, is when we're in the format of an exponential function, it's a, the first number outside of the parentheses. So here the y-intercept is 5, and my growth rate b in the parentheses is 4. 4 is bigger than 1, so this is an increasing exponential function. For b, same idea. The y-intercept is the number out in front, 0.5. Because the number inside the parentheses is bigger than 1, this is also increasing. In c, the y-intercept is the first number, 7. Now 0.9 is less than 1, so this is a decreasing exponential function. I want you to go ahead and pause the video here, try the next 3 on your own, and then we can come back and check our answers. Alright, hopefully you tried those on your own. Here indeed, the y-intercept is that first number 8. Now 2/3, you have to know your fractions. 2/3 is less than 1. I know that because the numerator is smaller than the denominator. That means the fraction is less than 1, so you are decreasing. For the next one, 125, that first number is your y-intercept, and 1.5 is bigger than 1, so this is an increasing exponential. The last problem here, 56, is my y-intercept. Now 3/2 is greater than 1. I again know that because the numerator is bigger than the denominator. That means the fraction is greater than 1, and it's an increasing function. All right, let's talk about graphing exponential functions. So you're going to need Desmos. I'm going to pull it up as... Okay, so you can use your graphing calculator, but I'm going to use Desmos here. We're going to look at an exponential and see what it looks like. So let's graph in Desmos y equals 8 times 2 to the x. Okay, so before we start, the 8 is my y-intercept, that first number. The growth rate is the number in the parentheses, that's 2. Since 2 is bigger than 1, we're going to be increasing. So let's go to Desmos here and check this out. We'll type in y equals 8. Now the growth rate has to go in the parentheses. Now to make an exponent, I'm not going to use squared because I don't need an exponent of 2. I'm going to choose the button that's next to it that says a to the b. It'll give me an exponent up there, and I'm going to put the variable x. And this makes a picture of my exponential function. So it looks like this graph is increasing, it's going up. Now let's fill in our table. So we'll click on the table button. I can at least have the numbers from -2 to 2. So let's fill those in. Right? So -2, it said the output was 2. -1 is 4. 0 was 8. 1 was 16, and 2 was 32. Now we just have a couple more boxes to fill in. So you would go back to Desmos. Remember, you have to type those numbers in. So -5 here gives you an output of 250. Oh, I did +5. I need -5. -5 is 0.25. -4 is 0.5. -3 is 1. Oops. jump up to 3 and 4 here. 3 is 64, and 4 is 128. So now I want you to take a couple minutes and plot those points very carefully. If I go to -5, 0.25 is really close to the axis, so just make it as close as you can and estimate. -4 is 1/2, so about halfway up. -3 is at 1. -2 is at 2. So now we can start to see that curved shape coming. -1, 4, 0, 8, 1, 16, and that's all that's going to fit on my grid. So I'm going to go ahead and connect those points the best I can, and that would be a graph of your increasing exponential function. Okay. So all we have here is just to remind you the things we've talked about with exponentials. The A right here is the y-intercept. B, they can call it the base, or they just call it the multiplying factor. I like to call it the growth factor, and that's what the teachers here at Hayes are going to call it, the growth factor. Okay. Let's look at this function. 10 times 0.5 to the x. We're going to do the same thing. We're going to graph this in Desmos. So if y equals 10 parentheses times 0.5 to the x power. Now this time you should look at that graph and notice that it's going the other direction. This graph looks like it's decreasing. That seems to make sense because, first of all, if I have 10 here, that's my y-intercept. And when I look at my graph and click on the axis, that is the y-intercept, 0, 10. Also, 0.5 in the parentheses is less than 1. That's why my graph is decreasing. So let's go ahead and build the table so that we can plot the points. So we need to, starting at -2, so it would be -2, 40. So go ahead and pause the video so you can see the screen here, and then we'll come back together in a second. Alright, hopefully you're able to use Desmos to fill in the rest of that table. It says, what point will g of 0 represent on the graph? So when I look at the table here, g of 0, 0 is my x value because it is in the parentheses. The output is 10. Well, we already said that 10 is the y-intercept. So when I graph this function, it's going to cross the y-axis at 10. So let's plot these points. I have -2, 40, which doesn't fit on my grid, but -120 does. 0, 10, 1, 5, 2, 2.5, 1.25, and 4.625. So you can see the shape of this graph is going down, and it is slightly curved. So the question is, what are we multiplying by every time? Because one thing I didn't really talk about here, because I wanted to get to this next problem, is that exponentials are all about multiplication. If I go back to the first example here, I should notice that to get from term to term, I'll start at the 1 just so it's easier to see. I multiply by 2 to get from 1 to 2. 2 times 2 is 4, times 2 is 8, on and on and on. I keep multiplying by 2. So I need to figure out what am I multiplying by in this problem to get from term to term. Now since the numbers are getting smaller, we're actually going to multiply by a fraction. And the trick to figuring out what the fraction is you're multiplying by is to take the second number divided by the first number. So 20 divided, I want to leave that graph up here. 20 divided by 40. And it tells you that's 0.5. So let's check it out. Let's see if 0.5 actually works for us. So if I take 20 times 0.5 to get to the next one, I get 10. And when I look here, 10 is the next number in the box. 10 times 1/2 is 5. Half of 10 is 5. So it looks like we are multiplying by 0.5, or you could say 1/2. Now the same trick applies when we go back to that first problem. Remember, if you're having trouble figuring out what you're multiplying by, you're going to take the second number divided by the first one. So here I'd have 0.5 divided by 0.25. So let's double check. Here. 0.5 divided by 0.25 is 2. And that's what we said our growth rate was for the first example. All right, so back to our decreasing exponential. It represents, it's asking me, was this growth or decay? Well, we know it's decay. We've been talking about that for two reasons. One, the b, the growth rate, which is 0.5, is less than 1. The other reason is because your graph is going down. Your graph is decreasing. Two more problems here. Let's look at some tables. This will help us figure out how to find that growth rate from a table of values. So we're going to write an equation, y equals. Now the y-intercept, I want to find y-intercept increase and decrease before I write the equation. The y-intercept always happens where x equals 0. So on this table, the first one, y equals 0 is the first number I see. So it has a y-intercept of 10. Now when I look at these numbers from spot to spot, it looks like the numbers are going up. So this is exponential increase. You can probably figure out what you're multiplying by to get from 10 to 30 and 30 to 90 and so on. But remember, the way you figure this out, if you're not sure, is you take the 30, the second number, divided by the first number. And 30 divided by 10 is 3. So let's double check. 10 times 3 is 30. 30 times 3 is 90. Times 3 is 270, and so on. So my growth rate is 3. So if I write the model, I already have y equals. I start with the 10, the y-intercept. I put my 3, my growth rate, in the parentheses, and x is my exponent. The next problem here, my y-intercept is at x equals 0. That's in the middle of my table. My y-intercept is 60. And I want to know how to get from 60 to 15, 15 to 3.75, and so on. So what I have to do, these numbers count too. We know it's going down because it's decreased because the numbers are getting smaller. So I'm going to take my calculator and I'm going to take that 240, the second number, divided by 960. Right? I need the calculator for that. So 240 divided by 960. Oops, that didn't seem to work. Let's try this again. Maybe I typed it wrong. Let's do 60 divided by 240. Oh, because we're in the table. That would be why. This Aldrich is messing up. Try again. 240 divided by 960 is 0.25. Right? So let's see if this is 0.25. So let's verify. 240 times 2.5. 0.25. Gives me 60, and that would be the next number in the table. 240 times 0.25 is 60. 60 times 0.25 is 15, and that also is the next number in the table. So that's my growth rate, my b. So here my equation would be 60 times 0.25 to the x power. All right, I want you to try the practice associated here, and then we're going to go right into modeling for real-life applications with exponential functions.